Hello everyone. Today we'll be going over the PSoC Creator Debugger tool. The good news about this tutorial is if you're a little uncomfortable with scope and how functions work, this might help you visualize what's actually going on because we will be stepping through the code line by line. That said, if you find yourself using other IDEs that have other debugging tools, you will already have the skill sets you need from this video that will easily transfer over. Admittedly, PSoC Creator has its own nuances, as does any microcontroller and its debugger, but because of that, you'll actually be much better prepared for other debuggers, and you might find that other debuggers are much more friendly to use. But that's okay. This is still pretty close to what everybody else does in their own development. So, um, general notes before you get started with debugging. Make sure your PSoC is plugged in, as you cannot use the debugger without it. You also should make sure that your code is built. And I should also mention the caveat being that sometimes the debugging tool will be rather finicky. So it may take a couple times of building, cleaning and building, or restarting the program, which is PSoC Creator, and start stopping your debugger just to make sure things are working. I have run into a number of times having to restart, but I think it's working now, so we'll get rolling before more weird things happen. These are completely manageable. It really is just a matter of patience. So take your time, be forgiving, and learn how to work around some of these nuances, and you'll be just fine. Thus far, you've been using UART as your debugging tool. And by that, I mean you've been probably printing out values to make sure you know what you're looking at, or you've been just checking, hey, does the UART even work, or is it spitting out garbage because you haven't set it up properly? While this is great for simple debugging, the more complex your code is, the harder it is to use UART for that purpose. So the debugger tool fills that gap because you have complete control, PSoC creator nuances aside, to navigate your code. So for this, you don't actually need to understand what this code is doing, but you do need to understand that we are going to take a look at scope, functions that call functions, and how to navigate around those things. So to access the debugger tool, you can click the little bug, type F5 on your keyboard, or go to the debug option and select debug, debug without programming, or select target and debug. Of course, select debug target is much like selecting your target to program, but you don't actually go through with these things. I would generally suggest select debug target and debug, either the individual options or the combined one. Generally, if you debug without programming, you may run into unexplainable actions or issues, so try to avoid that. When this code starts, you will find that there is a yellow arrow at line 27, and what that means is the debugger is right there. Not every debugger will start at initialization lines or execution lines. In fact, it will run straight through. So the way to deal with that is to add breakpoints which tell your code to stop. So with a left click, it seems the debugger is acting up again. Sometimes the debugger will let you say at line 34, 33, or other individual lines where things are being assigned. It'll let you stop at the line you want it to. Sometimes, though, PSoC Creator will not let you do that and it will force it to the next line. In these instances, you can try rebuilding, you can try stopping the debugging, you can rebuild and run, or you can try resetting. Any one of these options may be the answer for that instance, but for right now, we'll go over what these things do rather than waste the time debugging at the moment. So I've added a breakpoint, which basically tells the code to, hey, stop here. So if I were to resume execution, it will stop at line 37. And if you look at the call stack, which is one of the new windows with the debugger, you'll be able to see what line things are currently at. Though you have additional windows on the left side, such as memory 1 and registers, you generally don't need to worry about these two. Something else you'll find is the locals window, which tells you all the variables that are in the current scope that you're at. And you'll see that in the case of buffer, we can still look at what's going on. So we can see all our characters are in our buffer, which is pretty neat. And we've established an empty new buffer of length 11. So there's going to be some garbage values in here at random. It should mostly be 0, but there's going to be some weird stuff, as you can see. Don't pay too much mind to those. If you know that you're purposely just declaring something as we have in line 35, but in the cases of line 33, you generally want to make sure that the values match. Again, a nuance of PSoC is that these values may not represent what you need to, in which case, rebuild, reset, etc. So let's talk more about functions. So let's say we jump to that line. And what happens here is that we're calling a function. So we're left with two options. Also, a brief tangent, but still very relevant. You could put potentially a breakpoint at every single line if you really wanted to, presuming PSoC lets you for that instance, which it's not letting me right now. That's okay. To actually avoid putting a breakpoint at every single line and clicking play every single time, you don't actually have to do that. These step into and step over buttons effectively do step next, which is to say, go to the next line. However, when you are at instances where there is a function being called, their actions change, and it depends on what you'd like to do. In the event that you would like to skip over the function visually, but not executionally, you would click step over. And what that does is simply goes right back to the beginning of the for loop in this case, or to the next line of execution if there were more lines beneath this for loop. So in essence, it would continue going. And as I mentioned, you can't edit things. So this file and this file are locked. Generally ill advised to edit if you are able to, but in the case of PSoC, you cannot. However, you can edit values within your local variables. I would generally advise that you not edit unless you know that you need to, just to avoid unintended side effects. But let's say I wanted to watch a specific area. So in this case, I would like to watch the variable new buffer at the index I. And to do so, I would right click and add a watch point. It could be on read, which is when something is read from that index, on write, which is when something is written or saved to that, or generally on access. So regardless of whether it's read or write. Because I've already created this, I don't have to create another. But we do notice this nice feature that is hovering over things and getting all the values that are going on in that buffer. Notice though that you can't really access individual indices, not quite like the watch. So if I was at index I, which I believe is 0, we could also edit it through this aspect. We can't really change the type, which is fine, and we can't really change the memory address, but we can change the value should we intend to. These are the indices of new buffer. So if I wanted to add a new variable independently, such as C, there are ways in which I could just simply type C and it will add it. But you already notice that it tells us it doesn't exist in this context. And the reason for that is scope. C does not exist in this immediate code section. It does, however, exist in other function and sample function. So be careful when you add things, but know that there's different ways. So even if it's telling you it's an error, it may not be an error. So you'll notice that output doesn't tell us it's an error. But if something you were doing was in fact a warning, worth a warning or worth an error, it will probably turn out here. Otherwise, you'll get where it stops, and that's from breakpoints. You probably won't be in output window, you probably will be in the call stack. So let's say I wanted to step into the function this time, which is to say I would like to look at the internals or the body of the sample function. So I would say step into. Now, remember, it still works as step next unless it's calling a function. So if we hit step next, even though there is a breakpoint, it still works as a step next. And now we jump into the function. So we're back up to line 23, and our call stack is now 2 levels. Our main has been pushed down, and it's at the line number that it was last at, which was line 40. And the current line that we're at with the debugger is line 23. So we have car letter and we say, hey, we're accessing another function. If I wanted to, I could step over it and leave the function, return to the line 40 of execution, and continue on with my for loop. I could also call other function, which I could step into it, and then I could examine these. However, we also have this new feature, which is step out. So what if this was more than 2 lines, say 10 lines, and I really didn't care to sit through and go line by line or skip a few lines somehow to return back to my for loop? Perhaps I had a number of break statements. You'll notice that break statements stop whatever you're doing. So if you're trying to leave or enter a function, and there's a breakpoint in the way, it will stop at the breakpoint first, even if you decide that you want to step over something and skip it entirely. Please note, though, that you don't skip things executionally, you skip viewing it yourself. So, returning to step out, if we wanted to leave the function, this is what we would do, especially if we wanted to vacate it almost immediately instead of stepping through line by line. So let's jump back. And you can see we're at this same line, but we're actually conceptually at the end of the line because we finished our function call and we're probably in the process of either saving it or completing the execution. So we could hit play again and we're back to the for loop. I don't think that we checked it at that instance, but we probably had a valid C and an invalid new buffer. And you notice that the call stack is back to 1. And that's because we have popped the sample function off of our stack because we were no longer there. We left it. Therefore, our business there is done and memory handles it from there. So what if I wanted to check for a specific condition? Right now, if the line 15, if C is equal to L, what if I actually wanted to check when things are equal to O? So there are two O's in our character array. The way I can do this is one, stopping debugging and changing this, but what if I need this functionality? There's another way to check. Well, I really want to make sure that we're iterating through the entirety of the array. So I want to check what happens after L. I want to check O because I can't really tell if things have been moved around. So in order to check for O, I would create a new breakpoint. So first, click left or left click to create a new breakpoint, and then right click to decide what I'd like to do with it. I can delete things, I can disable things, I can make them temporary, change the location, count how many times they've been accessed or hit, or add a condition. And in this case, I want to say, hey, when it's equal to O, I want you to tell me about it. And I specifically want you to stop there. If PSoC is cooperating with you, this should work perfectly and it will only stop when you've hit O. If it doesn't, because it's overloaded by a previous breakpoint, which I think is what's been going on with me in my instance, it may continue to stop there even after you've told it conditionally to stop there. But presuming all works correctly, let's see what it does. So if we keep hitting play, you'll notice it's sticking at line 40, which is great. That means it's working as intended. And right now we're looking for the next instance of O, which it just found. So we have line 15, and here we are. You'll always be at line 15 to check the first condition, regardless of what letter it is. The line that you won't reach if it's not L is line 16, but if it is, you'll go to line 16. Otherwise, you'll go to line 18, which we can see by just clicking step into. Voila. And if we want to reach the end of the execution of the function, we'll click step into or step over again, and we'll find ourselves at the end bracket of the function. So you can see here that we can disable all the breakpoints if we want to just not sit there and delete things one by one by one. We can also edit things through the debug window, which allows you to create new breakpoints at specific things. Just delete them all, disable them all, toggle them, etc. And we can also use the steps here that are all found in the toolbar. So we've watched a couple variables. We have seen a couple locals. We have seen our call stack. And we've set a couple breakpoints of conditional value and of just general breakpoints. So with that, I think you're ready to go off and learn how to use the debugging tool on your own for your own stuff. As I mentioned, PSoC Curator can be a little bit finicky, but that's okay. Sometimes you just have to give it a bit of patience and it will work as you would like it to. But if you are running into these issues, definitely go ahead and hit stop debugging, rebuild and run, or reset, and perhaps that may solve your issues. And if it still doesn't, consider closing PSoC Creator and reopening it. That sometimes is enough to get it going, and sometimes it may take a couple times of starting and stopping the debugger based on the last many times I have recorded this. So if you are still running into issues, feel free to come into office hours and we'll work out what we can. But generally, these debuggers are awesome to see what's going on the other side, behind the scenes of your flow of execution, especially when things compile, but they're still not working. It's a great way to see if variables are populated without having to figure out how to print it out in the UART. So with that, Enjoy the rest of your week. I'll see you in office hours and enjoy debugging.